Okay, well, let's look at Lesson 1.5, Solving Inequalities. So here are our content standards, ACED 1 and ACED 3, and our mathematical practices that we'll be using, we'll be modeling with mathematics. So take just a moment to read those and then restart the video. So previously you have solved equations involving absolute values. So the objectives for this lesson is that we're going to solve one-step inequalities and multi-step inequalities. Only one new vocabulary word, it's set builder notation. And the key concept. I know this looks a little bit confusing, but in essence, this key concept tells us that adding the same number to or subtracting the same number from each side of an inequality does not change the truth about the inequality. So these properties can be used to solve inequalities. The solution sets of inequalities in one variable can be graphed on number lines. So let's look at an example. We are asked to solve using addition or subtraction. The inequality 5y minus 3 is less than 5y plus 2. Graph the solution set on a number line. We'll start with the original inequality. Now, as we're looking at this, we're looking at our y's. They're both positive. So we're going to keep the y on the side that's the largest y. So that's why we're going to start by subtracting 4y from each side. The less you work with negatives, the less chance of error you have. That's going to leave us with a negative 3 on this side, less than, and 5y minus 4y is y plus 2. Now we're going to subtract 2 from both sides because we're wanting to isolate this y. So if we subtract 2 from both sides, we will end up with negative 5 is less than y. Now we can rewrite it with the y first, so y is greater than negative 1. So notice negative 5 is still less than y in both circumstances. So any real number greater than negative 5 is a solution of this inequality. So it's because the inequality was just greater than, not greater than or equal to, it's going to be an open circle. So the point is not included in the solution set. So check your progress. Which graph represents the solution to this inequality? So pause the video, choose your answer after you've worked the problem, and then restart the video. So what answer did you choose? Good job. So x such that x is less than 9. So here we have a couple of more properties. Multiplying or dividing each side of an inequality by a positive number does not change the truth of the inequality. However, multiplying or dividing each side of an inequality by a negative number requires that the order of the inequality be reversed. So let's take a look at what that looks like working an example. So we're going to solve an inequality using multiplication or division. So looking at this, what are we going to use, multiplication or division? We will be dividing both sides by that negative 0.3. Now because we're dividing by a negative number, we're flipping the sign. We have to reverse it. So negative 40 is less than or equal to p. Or we could rewrite it with the p first. P is greater than or equal to negative 40. So the solution set in set builder notation is P such that P is greater than or equal to negative 40. And this is how I want you to write your solutions to these inequalities, with the braces and P such that P or X or whatever variable they give you. So because it says greater than or equal to, we're going to have a closed circle or a dot. That means that this solution is included in the solution set. And so anything from negative 40 and greater is in the solution set. Time to check your progress. So pause the video and restart it when you're ready to check your answer. Excellent. So our answer is x such that x is less than or equal to -7. And when we graph our solution, it's a closed circle at -7, and it's everything less than -7. So I want you to practice reading that. X such that x is less than or equal to 7. So don't forget the straight line means such that. So now we're to solve -x is greater than x minus 7 divided by 2 and graph the solution set on a number line. So let's simplify this. Let's get rid of this division problem. So we can multiply both sides by 2 to take care of that. So now we're going to move this x over, so we have -3x is greater than -7. Divide both sides by -3, which means we're going to reverse our inequality. So x is less than 7/3. So the solution set is x such that x is less than 7/3. And graphed, we have 7/3, and it's not or equal to, so it's an open circle, and it's everything less than 7/3. Time to check your progress, so pause the video as you work the problem. Awesome. Our answer in set builder notation, x such that x is less than -5/7. So on our number line, we graph 5/7 with an open circle, and it's everything less than -5/7. Now let's look at more of a real-world example. So pause for a moment and read the problem, and then restart the video when you're ready to go on. First of all, we need to understand what the problem is asking us. So we're going to let G equal the number of gallons of gasoline that Javier buys. The total cost of gasoline is $2.89 per gallon. And the cost of the pretzels and juice plus the total cost of the gasoline must be less than or equal to $15. Now for our plan, we're going to write the inequality. So we've got all of our costs and what it can be no more than $15. So the pretzels and juice are $1.59 plus $2.89 per gallon must be less than or equal to $15. Now let's solve our inequality. We're going to begin by subtracting $1.59 from each side. That leaves us $2.89 per gallon is less than or equal to $13.41. We divide both sides by 289 to isolate our G. So G is less than or equal to 4.6. Javier can buy up to 4.6 gallons of gasoline for his car. So since 1341 divided by 289 is actually greater than 4.6, Javier will have enough money if he gets no more than 4.6 gallons of gasoline. So time for you to work a problem to check your progress. Pause the video and then turn it back on to check your answer. Excellent. Jeb can drive up to 700 miles for that one day and not spend any more than $200 on car rental.